So in this video we'll be seeing how to brute force the Syscall numbers. So this technique is not stealthy, it uses virtual alloc function with page read write execute. So this is the Syscall stub, and the Syscall number will be moved into the EAX register before executing the Syscall. So this is the value we want. So if you wrote the NT DLL and PEBAR, you can see the NT functions will always start with this pattern 4C8B. So you can take any of these patterns. The only number will be this number. The after 4 bytes, this will be the Syscall number. So you can see the 2C, 2D, 2E, 2F, 2F30. So you can see the numbers are increasing, and the NT process is number 26 in hexadecimal. So this is the Syscall number. So EDR can also put the user mode hooks when the process loads the NTDLL, then the starting bytes will be some jump instructions, and also it can EDR can manipulate this value so that the number can be wrong. So it might do some addition or subtraction operation to confuse our parsing mechanism to get the wrong value. So we'll be just brute forcing blindly with the help of virtual alloc function. So that is the drawback for this method. We will be using virtual alloc function. So here are the bytes I have stored in the V array. So these 4 bytes are corresponding to the Syscall number. So the technique behind this, the logic behind this technique is we will be calling this NT open process function until we get the NT status as a status success. So you can see the documentation for this NT open process. The function returns status success if the call is successful. Possible return values include the following error status codes. So these can also be the status codes. So we can match the return value based on the status codes. If these are the status codes, then that means that Syscall might be that function. So let's go and do this. So first we have the number 1. So Syscall number 1. Virtual alloc v.length mem commit and page production is page execute read write. So let's call this as base. So you can get the Syscall number for virtual alloc by using some techniques like Hell's Gate. So if you got the Syscall number for virtual alloc, you can use directly that NTAllocate virtual memory function to get rid of this virtual alloc function. So for now we will be just using virtual alloc, and then write process memory. So what we have done is we have allocated some size of this buffer in memory, and we have written all of these bytes into this base address. So we are going to use for loop in 1.200. so let's just think of this higher range. So the NTDLL contains so many functions like 4000, 5000. So for now let's just keep it small. For in 1.200, from 1 to 200 we will be overwriting this 4 bytes with the I value. So std pointer right, destination is base as usize plus 4. Why 4 is the 4 bytes representing our syscall number starts after the 4 bytes, 0, 1, 2, 3, 4th byte. So after writing that, what we are going to do is we are going to cache this pointer as the function signature of this NT open process. So std mem transmute so the source one is star mute c void. This is the mutable pointer, the base address. We are going to convert this into a function pointer. So we need the function signature for this, that is NT open process. So copy this function signature, and paste it here. We are good to go. So let's call this as f1 function. Now I have already defined this function signature here, the entire members initialization. So the process handle will be written into the p handle variable, and process all access, and we will get the NT status. So if NT status is equals to status success, then we are going to print the syscall number. We are going to read those 4 bytes at the base plus 4 location. So we are printing the syscall number, also printing NT status and the process handle. P handle. And after that we can close this handle, and after the for loop we can free the allocated memory. So we are good to go. Let's run this. Okay, we got so many values. We need to break here. The Syscall number should be 26 in hexadecimal. I think okay, so we got the correct answer. So the Syscall number for NT open process is 26 in hexadecimal. We can also print the other NT status. So here you can see so many NT statuses. So one thing you need to be careful is status access denied. If you are opening a process handle to a high privileged process, then you will get this status access denied. So you need to be very careful for that one. You can that's why we are using the get current process ID to open process handle to ourselves. So that's why we will get always success. So that's how you can brute force the syscall numbers using this virtual alloc. If you know the syscall number for this virtual alloc, you can directly call the NT allocate virtual memory instead of this virtual alloc.